Helicopters have a speed limit that has nothing to do with laws. Well, unless you count the laws of physics. Hey, it's me, Destin. Welcome back to Smarter Every Day, the show where we do science. So today I'm going to explain to you something pretty interesting about the dissymmetry of rotor flight. But before we get too serious, let's just have a little fun. Check this out. Nighttime flying with Carl. Sick.
That is sick nasty.
Ready.
Not believe it.
Whoa! Yeah! I feel like I'm very... Oh, yeah! Right there. Okay, we're gonna do some light painting with a helicopter at night. Look real close. Go back to the image. If you look on one side, you see this really tight radius of curvature, but on the other side you see a much larger radius of curvature. What's going on there? Okay, so to explain the effects of this unsymmetric travel of the blades, I've rigged one up on a stick here. And I'm gonna try, let's see if this works. There we go. So as the advancing blade comes around, it's moving faster relative to the air because the helicopter is moving, so you add those two values together. But the retreating blade, you subtract away the velocity of the blade from the forward airspeed, and that's the total relative velocity of the blade through the air. This causes some funny things.
Okay, let's start the blades and check things out. As the chopper flies forward, the air flows over both sides of the helicopter. The advancing blade is also traveling forward, so this adds to the air velocity of the rotor on that side. Now, as long as the airspeed of the rotor stays under the sound barrier, you're okay. But if the helicopter goes too fast, you'll create shock waves and start to damage things. The retreating blade sees the same airflow of the vehicle movement, but because the blade is traveling in the opposite direction from that movement, the actual airspeed of that rotor is less. This creates something called dissymmetry of lift. And to counteract this, the rotor on the retreating side is given more pitch to produce more lift. This works up to a point, but if the helicopter goes too fast, the pitch becomes too great and you lose lift, creating what's called a retreating blade stall.
The cool thing about a retreating blade stall is that it's a self-correcting problem. If you think about it, due to gyroscopic precession, if you have a dissymmetry of lift between the left and right side of the helicopter, it won't roll the helicopter like you think it would. It actually pitches it. That's a good news because as you're flying along, if you get too fast and you get a retreating blade stall, it'll just slow the helicopter down automatically. Okay, there's a lot of things I did not cover in this video series, but for the most part you should be way smarter than when we started on helicopters. Smart enough, in fact, where you can make an educated guess as to which of these three helicopters is the fastest in the U.S. Army inventory. While you're thinking about that, please consider going to the Facebook page. I'll put all the photos from the night flights on there. Go download them, use them as your desktop background, stuff like that. While you're there, please like the Facebook page. Also, if you have ideas for future Smarter Everyday episodes, please tweet me. I'd appreciate that at Smarter YouTube. It's been about a year since we started Smarter Everyday. If you have ideas for a one-year episode, I'm all ears. Okay, enough babbling. The answer is the Chinook. It is the fastest in the U.S. Army inventory. I'm Destin. You're getting smarter every day. Have a good one.